Tùng. Okay, so continue. Um, I will share with you some example about whether we consider the negative time or not. Okay. Yeah. Okay. So let me check. Okay, you can see my screen. Okay. So now we take example. Okay, just basic example. Okay. Yeah. So now, when we mention about electrical components, we have resistor, right? We have inductors and we have capacitor. Okay, so if we have the voltage, okay, this is R and this is V and this one is I. Okay, so we have we have this width here. We have this width, right? So if we turn on, okay, yeah, we can, if we turn on, we can get the current flowing through the resistance. Okay, yeah. So because this is resistor, so the resistor cannot store the energy, right? So if we consider the time when we turn on this switch, okay, here, this is energy. This one is times. Okay, yeah, when we turn on the switch, this is 0. Okay, 0. And yeah, when we turn on the switch, yeah, we have the energies, right? The energy is E B times T. B is what? B is the powers. E R I square. Okay, so you get R I square times T. Okay, we have the energy. So when we turn off, okay, we don't have any energy stored in the resistor. Okay, so we don't care about if uh, if we consider the time when we turn off. Okay, here is maybe here is T. Okay, so no energy storage in the resistance. Okay, so we just consider positive times. Okay, but now for inductor or capacitors, we have the energy, right? So if we have the voltage, okay, and we have this width here, and here we have inductor, right? Okay, L, V, and I. So we can calculate energy storage in inductor. This is WL. WL is 1 over 2 L I square, right? I square. This is the energy storage stored in the inductor, right? I'm right. 1 over 2 Li square. Is that correct? Okay. So now this is energy. And this one is T. Okay. So when we turn on the switch, okay, we have the energy, we store it. We store it. Will be stored in the inductors. And when we turn off, okay, and then you stay here, okay, and then your hand touch here and your leg touch here, so the energy will discharge into your body, and then you will be you will be die, and you need to say goodbye with your parents because you are die. Do you understand? So now when we consider inductor or capacitors, we need to consider the energies before you turn off this switch. Okay, that means you need to consider T0, because if T0, that means the time you turn off, right, this switch. Okay, so when you turn off the switch, you need to release the energy stored in the inductors before you do something. Otherwise, the energies will discharge into your body, and then say goodbye to your parents. Okay, because you will be died. Any questions? Yeah, so if we have L and C component, okay, component, you need to consider T0 minus, that means negative times, okay, the initial condition. Okay, negative time, we say initial condition. Okay, that means we have some value at the initial condition. But now we don't care. We don't care because initial condition, the energy will be 0. Okay, so this is the some typical, some common example of of negative times or positive times. Okay, and of course, similarly, we can analyze the capacitor's energies. Okay, so we have what? We have WC is 1/2 C square. Okay, this one is energy to be stored in the capacitor. Okay, just some example. Yeah, and okay, yeah. Of course, we have many different combination of RLC. You know, we have, for example, we have RLC in parallel. In parallel, we have RLC in series, and you know, we have many random combination of RLC. Okay, yeah, we will study this one from physics 2 or electric circuit. Okay, covered by Dr. Hiển and Dr. Udo respectively. Okay, anyway, we come back. Yeah, I hope you understand. Yeah, and this one is more general, you know, more general. Yeah, of course you are right, but more general. You consider these time axis. Okay, yeah. Okay, we go back. Okay, to study theory. Okay. Now we consider the instantaneous speed. Instantaneous speed. Yeah. So the instantaneous speed of a particle is defined as the magnitude of its instantaneous velocity. Okay. Yeah, similar to average speed. Okay, similar to average speed. Instantaneous speed is a scalar quantity. We don't care about the direction, you know. Yeah. So if we have the magnitude of instantaneous velocity, it will become the instantaneous speed. Okay. Yeah. For example, as with average speed, instantaneous speed has no directions associated with it. Okay, as I mentioned before, for example, if one particle has an instantaneous velocity positive 25 meters per second along a given line, and another particle has an instantaneous velocity of minus 25 meters per second along the same line, so both of them have the same speed, 25 meters per second. Okay, so up to now you understand, right? You understand what is instantaneous velocity, what is the instantaneous speed. Okay, yeah, yeah, okay, yeah. So look, of course, when we calculate the instantaneous velocity, okay, when we calculate instantaneous velocity with x, okay, this is the limiting of delta x over delta t, I overhead delta t is approaching to 0, or we just take the derivative, the first derivative of x with respect to times, because x, this is position, you know, x is the function of times. Okay, the position is the function of times, so we can say it's xt. For example, we have a square t plus b, a t square. Oh, sorry. For example, we have quadratic equation. Quadratic equation is a t squared plus b t plus c. Okay, so when we take the first derivative of x with respect to times, you can get Vx, okay, instantaneous velocities. Okay, yeah, yeah. Or what is it? This is slope. This is slope. Okay, this is slope. And here you can, yeah, look, the instantaneous implies the derivatives of the function of times. Okay, we use italic. Why? Because this is the function of time, you know, this is variable, the function of time, so we should use italic. Okay, so yes, now the summary. So instantaneous velocity, with this is a vector quantities. That's why we should consider magnitude and direction. So the magnitude of v at a given instant is the speed of the particle. Okay, yeah, that's all. We have some example here. This is for your reference. Okay, you need to think about this example for yourself. It's very easy. So we don't have more time, so I just very quickly explain to you. So consider the following one-dimensional motions. A pole flew directly upwards, rise to the highest point, and fall back into the lower hand. Okay, so consider. Okay, so are there any point in the motion of these objects at which the instantaneous velocity had the same values in the average velocity? Okay, over the entire motion, and if so, and then identify the point. So to answer these questions, you need to know what's the difference between instantaneous, right? Yeah, instantaneous and average velocity. Okay, so instantaneous, you get the Vxa limit delta x to be 0 is delta t is approaching to 0, right? Sorry. Okay, delta x over delta t or equal to the first derivative of x with respect to time, delta t, and average velocity Vx average, that's E delta x over delta t. Okay, yeah. So they are the same. Okay, so that means the instantaneous velocity has the same value as the average velocity. Okay, so if the same, that means, for example, we have this is x, this is times. Okay, so if we have yes, if we have the linear curve of x versus times. Okay, so when we consider point A here and point B here, okay, so you can guess here is delta t and here is delta f and delta x. Okay, so you can get Vx average E delta x over delta t. Okay, so when we enrich delta t, how many times we enrich delta x, how many times? Because it is linear. Because this is linear. So if here is the linear curve, so we have Vx. We have Vx, you know, the same, you know. For example, here is the Vx, you know, Vx. Vx, sorry, maybe I use a different colors. Vx, 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 Vx. Okay, so we have the same Vx. We have the same Vx for any point of the times. Okay, so if we have x versus times like this curve, we can say that instantaneous velocity will be equal to the average velocity. Okay, do you agree with me? Okay, so yes, we now if we Yeah, if we get this idea, we check. Okay, so now if a pole throws directly upward, okay, upward, right to the highest point, this is the highest point, okay, and then fall back into the roller hands, okay, at roller hands. So you know there is one point with instantaneous velocity is zero, okay, at the top of the motion. Okay, so if here, if you get at the top, okay, of the motion, okay, so we have this is linear curve, right? This is linear. Okay, because at that point Vx will be zero and Vx average is also zero, so we have the same values. Okay, so look, okay, we get the answer. Okay, there is one point, okay, at which the instantaneous velocity is zero at the top of the motion. Okay, or here maybe not directly, yeah, directly upward, right to the highest point. Okay, a race car start from the rest and speed up to 100 meter per second. Okay, yeah. So yeah, we don't know exactly. We don't know exactly uh, what is the time the velocity will be equal to the average velocity. So we just say because the car will have every instantaneous velocity between 0 to 100 meter per second at some times. So there must be some instant at which the instantaneous velocity to be equal to the average velocity. Okay, and look, a spacecraft drift through space at constant velocity. Constant velocity. That means we keep the instantaneous velocity to be constant. Okay, so instantaneous velocity to be constant like this. Okay, so that means yeah, any times, any point, okay, the velocity, instantaneous velocity will be equal to the average velocity. Okay, so here maybe not upward directly, maybe it's like this. Okay, like this. Okay, also upward, this x, this is y. Okay, also upward, but here the velocity will be changed. Okay, so that means we also get the highest point where the instantaneous velocity is equal to this average velocity. Okay, yeah, very easy, I think. So for now we have example. Determine the displacement of a particle in the time interval t0 to t is 1, t is 1 to t is 3 seconds. Okay, we have x versa times like this. Okay, point A to point B, point C, point D. So for t is 0, you get point A, right? Point A, and t is 1 second, you get point B. You get point B. So we calculate displacement. So point A means xia 0, and here you get xfa how many? Minus 2. Okay, so you get delta x is xf minus xi, and everything minus 2 minus 0, you get a minus 2 here. Okay, and similarly, that t is 1 seconds, this is point C, and t is 3 seconds, you get point D. You get here, right? So now at point B, you get the ti is 1 second, xi is how many? Minus 2. And at the point D, we have TFE 3 second and XFE 6 meter. Okay, so now we have delta X is XF minus XI. You get 6 minus of minus 6, right? Minus 2, right? So you get A meter. Okay, very easy. Any questions so far? No questions? So continue. We calculate the average velocity. We calculate the average velocity. Yeah. During the 2 time interval, maybe we calculate the average velocity from point A to point B. Okay. So the average velocity follow x-axis from point A to point B E delta x A to B divided by delta t A to B. Okay, delta x we calculate before minus 2 and the time is 1, so you get minus 2 meters per second. Okay, and average velocity from B to D. Okay, you get here, very easy. Okay, instantaneous velocity. Instantaneous velocity of the particle at t is 2.5 seconds. 2.5 seconds. Okay, here is 2 seconds, so here is 2.5 seconds. So 2.5 seconds, you get point C. Okay, point C. So we have point C. Point C at the instant times. Instant time TE 2.5 seconds. So that means we need to calculate limit, right? Vx e limit delta t is 0. Okay, delta x delta t is approaching to 0, delta x over delta t. Okay, do we have x? Do we have the function of x? No, we just know xe linear curve, but we don't have the function of x. Okay, so we cannot calculate the limit because we don't have the function of x. But you should remember we have the tangent line. That means dx over dt I overhead. Okay, so this is the tangent line. The tangent line. So if we can draw the tangent line, if you can draw the tangent line like this, okay, yeah, here I mentioned before, here this is the tangent line, right? So if we have the tangent line, yeah, if we have the tangent line, okay, you can pick off. Okay, so we know this is the instantaneous velocity vector, right? Yes, this is the instantaneous velocity vectors Vx. Okay, so we just pick off randomly 2 points here because Vx is the slope. Okay, yeah, according to this tangent line. So if I just randomly choose this point and this point, okay, so this point is 1.5 seconds, and you get xe minus 4, and for this point you get 3.8 seconds, and you get x is 10. Okay, so now you can get the slope Vx. Okay, the slope Vx. So now the slope E dx over dt, okay, equal to here you get x how many? 3.8 seconds, you get 10 minus 4, right, over by 3.8 seconds minus 1.5 seconds, and then you can get 6 meters per second. Okay, so this is another way we calculate the instantaneous velocity. Okay, and we don't care about the function of x. Okay, so if we have the function of x, very easy. You can take the limit. You can take the first derivative of x with respect to time. But if we don't know the function of x, you need to draw the tangent line. And then you just set up two points randomly at the tangent line. For example, this point and this point, you can get time and this time and displacement, Okay, and then you apply the formula. We can calculate the slope. So the value of the slope is the instantaneous velocity. Okay. Any question, please? So far, any questions? Okay, so I will check whether we have the question or not. No questions. Maybe I will ask someone to make sure you understand what I'm teaching. Đỗ Anh Kiệt, any questions? No response. Okay, so TA, please check him. Oh, yeah. Otherwise, you know, if I cannot get any response from you, that means I think you are absent and you don't have any choice to demonstrate. Yeah, you are here, okay? Because when I call you, you keep silent, okay? Yeah, to be careful. Yeah. Okay, so okay, yeah, so come back. Yeah, we finish. Okay, and okay, yeah. Now, summary. Okay, the position versus times. Sorry, the position to the velocity. So this is the position versus time, right? This is the position versus time. Okay, non-linear. Yeah, position versus times, non-linear. Okay. Even though if we consider the horn curve, yeah, they are non-linear curves, right? But if I divide the horn curve here into three regions, this one, this one, this one, this one, this one, this one, they becomes linear. They become linear. Okay. So if here is a linear curve, you can calculate slope very easy, right? Okay. For example, here, if t is 0, you get x is 0. If t is 2, you can get x is 100. Okay, so we can get the slope. What is slope? Slope is instantaneous velocity, right? The slope means instantaneous velocity. So the instantaneous velocity is what? 100 over 2, and then you can get 50 meters per second. Okay, so if here I draw this is Vx, this is times, right? Remember, Vx means instantaneous velocity. Okay, so this is 0, 2, 4, 6, 8, 10. So here maybe 3, right? So from 0 to 3, you get Vx how many? 50. Here 50. Okay, and then you can get Vx like this. Constant, right? Constant 50. Continue. Now, here, from 3 to 6, this is linear curve, and then you can get slope, or Vx is what? At 6, you get maybe 250, maybe. Okay, and at 3, you get 200. Okay, yeah, divided by how many? 3 seconds. So you get 50 over 3, 50 over 3, nearly 17. Okay, so next one, from 3 to 6, you get 17, somewhere here, 17, right? And then here, maybe we get 100, okay? And just assumes this is 100. Then here, okay, you get 100. So this is the curve of Vx, okay? This is the curve of Vx, instantaneous velocity, okay? Here, you know. So if here in linear, if we have linear of x, so if we have linear of x, we have constant of Vx, you know, linear of x, constant of Vx. Okay, so if we have constant of x, we have 0 of v, because v is e dx over dt. So if x is constant, so the derivative of x will be 0. If the x is linear, so the first derivative of x with respect to time will be constant. Okay, like this. I hope you got it. And okay, so that is the reason we have the sentence here. The slope of an object's position versus time graph is the object's velocity. The object's velocity at that point in the motion. Okay, so yeah, so that means here I draw here, right? This is what? This is x. This is x. Okay, like this, you know. This is x. X versus times, and this is velocity versus time. Okay, and yeah, I already explained to you, right? Yeah. So we have if we have x, this should be linear. This should be linear or constant. Why? Because you can calculate Vx very easy. So sometimes x is not constant. So sorry, x is not constant or linear like this. This is x. So how can we do? So if we have the curve of x like this, you think about we divide it. We divide it into many regions. For example, if here is T1, so from T1 to T2, you can get a little bit, right? A little bit linear. Okay, so from T2 to T3, you get linear. Okay, from T3 to T4, you get linear. Of course, this one is approximation methods. Approximation, yeah. So if we divide more delta t's, more regions, okay, so they will become more linear, and then we can calculate Vx to be more accurate. Okay. Okay, can you get my point? Any questions so far? And we know for Vxe dx over dt. Okay. Yeah. So yeah, again, so if we have Vx time dt is e dx with integration of both sides, you can guess dx, right? Is Vx time dt. Okay. So here this is x. Okay. Yeah. So when we take the integration here, okay, for example, this is ti, this is tf. This is xi, this is xf, so you get the area, right? The integration mean area. Sorry, we need to calculate error here, you know, because this is x, this one is Vx, okay? So here, for example, here is ti, here is tf. Ti, you can get xi, tf, you can get xf, and then you can get this area, right? So this area is delta x, because delta x is Vx times delta t. Okay, and this one is Vx, right? This one is Vx. And Tf minus Ti, you can get delta T. Okay, and then when we take the product of Vx with respect with the times interval, you can get displacement. Okay, yeah, I hope you understand. Displacement will be calculated here. So these areas is displacement. Okay, any questions so far? No questions? Good. Okay, 1 minute. I will waiting for you. Any questions? Okay, yeah, good. Continue. Okay, yeah, I think it's very easy for you. Now we have multiple choice question. Are you ready? We have some extra point. Okay. So look. Okay, try to use your laptop. Okay, try to type your answers quickly as possible when I say start. Okay, now here is a motion diagram of a car moving along a straight road. Okay, this one means one dimension. Okay, one dimension. And this is 0, you know, you stay here, you stay here. Okay, you stay here. So that means here is y and here is x, right? X. So the questions, with velocity versus time graph matches this motion diagram. So first of all, you need to think about what is the curve of x versus times. Okay, x versus time. For example, here, if here is x, here is time, you know. Now to be careful because you stay here, so we have some negative and positive times. Okay, so for example, here I say t, t1, t2, t3. So here should be t3, t2, t1, and here is t4. T4 is 0, right? And this one is t5, t6, t7, t6, t7. Okay, so now look, you know, we have the same delta t. Okay, and the same distance, right? The same distance, or the same displacement, delta x, this one minus this one, delta x, this one minus this one. Okay, delta x, this one minus this one. So the same delta x and the same delta t. Okay, so if and of course t7 higher than t6. Okay, so if you can get this one, if here is 0, you can get the curve something like that. Okay, right? X something like that. Okay, t5 x5, t6 x6, t7 x7. Now here, you know, we have the same displacement, but delta x is negative. Okay, delta x is negative. So here like this. Okay, here delta x is negative. So you get this one, right? Right. Okay, the curves, imagine the curve of x like this. Okay, delta t the same. Okay, delta t is negative. For example, here is -1, -2, -3. So we have delta t here is minus 1 second. Okay, minus 1 second, minus 1 second, minus 1 second. So delta t is negative, right? And delta x is also negative. So you get the curve like this. The curve of position like this. Okay, so now A, B, C, or these, which one is correct if we consider velocity versus times graphs to match this motion diagram? Okay, so now 11:29. Come on, is it? Remember 11:29, not 28. Actually, delta x is smaller, you know, so should be like this. Okay, like this. Yeah, we get the curve like this because delta x is smaller. Okay, so if we have the same delta t and different delta x, so you get the curve like this. Just a sum, okay? Because we don't know what exactly, so what is the
So I have a question.
yeah. Okay. Yeah, please tell me.
I see that.
Okay.
Let me type them.
Okay, so maybe you answer first and then you type the question later. Okay. Okay, so finish and the answer will be C, of course. Okay, so now, okay, so 12. That means it's 11:29. Okay, because I forgot to change the time zones. So 11:29. Oh, a lot. Let me check. Okay, here 29, and we have 3 person. Okay, Trường Thắng, C. Okay, you are correct. C, right? Yeah, C. So Trường Thắng 1, Trường Thắng at 1% extra points. Okay, please tell TA, okay, to update your extra point into the Excel file. Okay, yeah, congratulations. And question, please. Question? Any questions? Yeah. Okay, please ask me. Oh, question here. Short. May I ask, isn't we consider the initial point at the left side? I think you should check from the start. Yes, of course, you can consider at the started. Okay, that's okay. That's okay. Yeah, yeah. But you should remember for this question, they require us, okay? They require us to consider here is 0. Look, here is 0. Here is 0. Okay. So we need to follow the sequence. Sorry, we need to follow the questions. You need to set up. You need to set up the origin here. Okay, because the questions ask us to do that. So if for the final exam or we have another case, another cases, they don't say anything about the time, you can choose the origins will be here. The origins will be here. Okay, yeah. So yeah, so if the origins will be here, that means we can get C, right? Because now they choose the origins here. They choose the origin. But actually, if here is origins, you need to get this one. Yes, this one. This one. Okay, so both of them are correct. Okay, just yeah, actually, if we follow the answer here, here must be 0. Okay, good. Okay, this is the first questions. You got it? Hoài An, have you got it?
No, sir.
Okay, so then what yeah the same questions. Okay, what if the origin at the time of time is at x0? Yeah, okay, yeah, it's similar to the question here. Okay, so yes, okay, you're correct. Okay, so this is the problem with my lectures. Okay, yeah, so sorry. Okay, actually, yeah, they should be here, right? Yeah, so sorry. Okay, yeah, maybe yeah, you understand the idea, right? Okay, so okay, thank you very much. Yes, you should share. We should shift the y-axis to the right for C. Yeah, okay, okay, correct. Okay, thank you very much. Okay, yeah, correct. So since there was a negative time period before 0, shouldn't the lower part of the will be after? Yes, of course. Yes, of course. Okay. Okay, yeah, you are right. Yeah. Okay, so all of you got it. Okay, get my answers. Okay, yeah, thank you very much. So if you read, yeah, yeah, okay, yeah. So here, yeah, or either none of both. But as I mentioned before, because I am wrong here, okay. So if for the final exams like this, okay, C is also correct. Is also correct. Okay, yeah. Okay, good. Okay, sorry. Maybe for final exam, I will double check. Yeah. Okay, to make sure everything is correct. Okay, thank you for your remind. Okay, to me, yeah, good. Okay. So for maybe here, maybe someone's answer E. Let me check. Okay, so if you get E, you also get correct answers. Okay, so yeah, let me check again. Oh, okay. So now I will finalize again. Okay. So for Trường Thắng, C, Quốc Bình, Ý, and Hoàng Minh. Okay. Okay. Sorry. It's okay. So again. Okay. Again, Trường Thắng, good. Trường Thắng, Quốc Bình, and Minh Quân. Okay. 3 students. Okay. TA, please. When I finish the theory of the lectures, okay, they will come to you and then ask you to add extra points into the Excel file. Okay. So again, Trường Thắng, Quốc Bình, and Minh Quân. Congratulations to all of you. Okay. So continue. I hope we have one more. Oh, yes. Oh, yes. Now, here is a motion diagram of a car moving along a straight road. X, okay. So for now, um, you start here. Yeah, you start here. So here is 0, right? Time is 0. Time is 0 will be here. Okay. And this one is x is 0 here. Okay. So for now, yeah, I will analyze to use this is x. This is times. So if I consider t0 here, okay. So for this is t1, t2, t3, t4, t5, t6, t7. Because this is t0, and then we come to the negative direction. So here is t1, t2, t3, t4, so on. Okay, so you know here you get delta t1, delta t2, delta t3. Okay, and higher. Or maybe we assume, you know, we assume we have the same delta t's. Okay, for easy. Okay, we have the same delta t, right? Delta t, delta t, delta t, delta t, t5, t6, t7. Okay, now look, delta x, delta x1, delta x2, delta x3. Okay, so if we take the absolute values, because this is, you know, we or, you know, or to be careful, you know, because time is here, but x is here. Okay, so that means delta x is positive, not like, because this is the origin, the beginning of x. This is the beginning of times. Okay, so we have delta x. Yeah, anyway, we have delta x n higher than delta x n minus 1, blah blah blah, higher than delta x3, delta x2, and delta x1. So that means, you know, yes. Okay, like this. Yeah. So this is the linear curve of x. Okay, with respect to times. Okay, now with velocities versus time graph matches the this motion diagram. Okay, we have A, B, C, D, E. Remember time here. Okay, time here. Okay. Or if you, yeah, if we consider time here, so maybe we move the x-axis here, y-axis will be here, because time is 0 here. Yes, okay, 0. Vx, right? Vx, 0, 0, 0, 0. Okay, now I set of 11:42. Okay, come on, do it. Mấy đứa nghe thầy nói không? Mấy đứa khác nghe nói không?
Yes, we
Okay,
can.
so yeah, so yeah, I'm so sorry because we had a problem with the internet, but that's okay. Yeah, we have the answers. Of course, this AB. Okay, but yeah, no, we had the problem with um, we had a problem with the internet. Okay, so just skip it. Just skip it. Okay. Damn it. Okay. Yeah. So from yeah, it depends on the it depends on anyway it depends on the time interval, so usually the beginning of times. So if here a x, here a t is 0, so you get like this. Okay, because the slope increase. Okay, so if you consider here is time and x, okay, you can get here and here. Okay, yeah. Sorry. We consider here, sorry, we consider here and here. Okay, so anyway, it's, the correct answer should be B. Okay, so for now, I will check the times, maybe just one more questions and then we finish. So now, look. Okay, now it's very clear, you know, because they give directly x versus times, v versus times. Okay, so a graph of position versus times for a basketball player moving down, you know, the court appears as the follow. Okay, which of the following velocity graphs matches the position graph? Okay, so this is the last multiple choice question today, right? So we are set up 11:49. Okay, come on. Do it. Okay, finish. So now, you know, this one is x is constant. Okay, and this one x is linear. Okay, so when we calculate the x over dt, you can get the x, right? So this is one constant, so you get 0. So we can delete this one. Okay, we have this one, and this one. Okay, now look, this is slope. This is slope. And if you study before, right, this is time and this is Vx. Okay, if like this is positive and like this is negative, right? We studied before, right? Which slide? I don't remember. I don't remember. Here. Okay, here. Yeah. Okay. So now if we update, we apply this information into this one, you know, so you get the velocity will be negative because they slope like this. Okay, so we delete this one because this is positive. So this one, but this x is linear, so we x is constant, right? So we delete this one. So the right answer will be C. Now I check. Okay, yeah, we finished. Okay. Oh, we have many multiple choice. So next week we continue. Now I check the answer. So the right answer will be C. And what time I set up? 11:49. No one. No one, right? Tùng, can you hear me?
Yes, I can hear you.
Okay, yeah, maybe we have some lag. Okay, oh my god. Okay, forget it. We don't have enough time, so no one gets extra points. Okay, forget it because we have some lagging. Okay, forget it. So now we finish the lecture today. Yeah, slides 63, and see you next week for physics 1. We continue 63. Okay, now the time for TA. The TA you have from the okay. So the time for TA will be 11:52 to 12:15. Okay. Now the time for TA is, if you don't understand, STA. Okay. Any questions so far? Okay, so we finish the lecture today. Goodbye. See you tomorrow morning with linear algebra courses. Okay, bye bye.